Week 5 lecture notes, fundamental counting theorem. We're going to be working on some probability in this section, and I'm going to start with a simpler example than we have here so you can physically see how the fundamental counting theorem works. I used to reward my 8th graders with ice cream sundaes after they'd finished their probability unit. And I usually gave them two choices for ice cream. They could either have vanilla or chocolate. And then just to save me money, chocolate. Can't even spell today. To save me money, I kept the toppings to a minimum. So their next choice would be 3 different toppings like sprinkles, nuts, and maybe, what else could we do? Sprinkles, nuts, and cherries. Alright, and then I usually limited the syrups to 2. Usually they liked strawberry and the hot fudge. And then I'd always ask them before they got this reward, how many different possible sundaes could someone make if they were trying all the different possibilities? Well, you can make a tree diagram for this, or you can make a list, and you can see what all the possibilities are. For instance, somebody that likes vanilla ice cream, they'd have a choice of vanilla with sprinkles with strawberry. Now that's if I'm limiting them to just one ice cream, one topping, and one syrup. So that's how this problem is going to work. Now that same person could change their mind and instead do vanilla, sprinkles, and hot fudge. Or they could do vanilla and nuts and strawberry. Or they could do vanilla, I'm going to start to abbreviate, nuts, and hot fudge. Okay, I'm tired already of writing this all out. Okay, let's say they didn't want vanilla and nuts or sprinkles. We still have one more choice. We could do vanilla and cherries and strawberry, or vanilla and cherries and hot fudge. Okay, we still have a ways to go because then we'd have to do all the chocolate. But can you see that the chocolate would be these same choices here, but only I'd be writing chocolate instead. So far we have 1, there's another vanilla, 2, 3, 4, 5, 6 possibilities. And if I did this all over again for chocolate, I'd have 6 more possibilities, right? For a total of 12. Well, let's look what's going on here. I'm doing the choice vanilla times 3 different choices for the toppings. 1, 2, 3. Sprinkles, nuts, and cherries. And then that gets multiplied by 2 choices, strawberry or hot fudge for the syrups. So the simpler, quicker way to do this would be, I've got 2 choices for ice cream times 3 choices for toppings times 2 choices for syrups. 2 times 3 is 6 times 2 is 12 possibilities. This is the fundamental counting theorem. If I can do the ice cream 2 different ways, the toppings 3 different ways, and the syrups 2 different ways, then all the possibilities are these 2 times 3 times these 2, or a total of 12.